Good afternoon, everyone. Uh, so, to start with, I don't want to make this a very technical talk because it can be boring for a lot of people. So, just how many of you have actual idea of what a container is? Uh, Anybody? Okay, I see a few hands. Yeah. And how many are familiar with the term API? I think, yeah. Okay, few more. Um, okay, so I'll just briefly explain what these are and why they're relevant in terms of AI even more. So, basically, a container is what you can say a standard way of shipping your application on the server side. It's an industry standard, and basically, whenever you're using any application, whether it be even your Swiggy, Zomato, or anything like that, so at the back end, the server which hosts these applications, they are packaged into what we call containers, and then they run on these servers. And APIs are mostly application programming interfaces, which if you have already seen some demos around using ChatGPT or Gemini through a prompt, that is one-to-one way of interacting, and in cases where you're using these models to build your own applications, you would be using their APIs to interact and program with them. Um, so in case of AI, up till an year ago, these things were working for us because mostly the companies and the applications which were being built in India, they were using APIs from Gemini or from ChatGPT, and they were deployed in the backend, solving these different use cases. And they were mostly Python applications, Go applications, and the actual heavy work was being done by these models, which were sitting in data centers of giants like Microsoft, Azure, and AWS, or Google, for example. But now, as you see that even in the AI summit that we saw earlier, that a lot of push has been towards AI being developed in India. We have seen models like Servam coming up, and the government is also pushing to have a lot of GPU based data centers in India now. Um, so now there's a shift where you want to move these workloads, which are your models, which are very heavy and huge, and run them in these high power data centers, GPU data centers, basically. And now that you see this change, we also have to adopt in terms of the way we package and deploy these models on these data centers. And the traditional way of packaging and deploying these applications to data centers are basically not going to take into account because there are certain limitations over there. So basically, I'm going to talk about them and like why do we need to uh, invest in this area, and also it's a big place where a lot of innovation is needed here in India, where uh, the companies can come up with solutions in this area. So, uh, So first of all, when we talk about GPUs, when the need for GPUs is that the AI models are very big and they require heavy calculations for what you query and talk to them. And that is why if you run it on a normal server, normal CPU, it's not going to give you efficient results in efficient time. So you basically need to run them on GPUs. So your data centers need to be GPU data centers, first of all. And up till now, as we talked about, that not a lot of companies or models were being developed in India and being run on Indian data centers. Now that scenario is changing. So previously, it was okay that the government subsidized few GPU data centers, and there were very less number of people who wanted to deploy their own models on those GPUs. So there was not a talk about utilization versus wastage in terms of money, in terms of power. So what was actually happening was every GPU machine was being given out to a single customer, and you would basically see that they would not utilize the entire power of that GPU node, but that's still okay because there was not a lot of demand for other models to be running at the same time. Um, and also there was a cost wastage effect in this area where both on terms of the user who wants to run their model and the data center who is running and providing the electricity and the cooling and everything. So uh, now that we have more models, more data centers coming up, and in the next few years, we are going to see a surge of Indian models being deployed on Indian data centers. There's going to be a huge demand in the efficiency and the way how efficiently and cost effectively you can run these models on these data centers and then GPUs in there. Uh, so as you can see, uh, in the traditional dedicated GPU, you basically give out the entire GPU to one customer who is going to use that, but might not utilize it to the full potential. But he still has to bear the cost. And even for the data center, it's like he is paying for the whole GPU and he's billing you for the entire machine. Uh, what is exactly being done to mitigate this problem is that you can actually partition a GPU and give these partitions to different tenants. As you can see on the right, we have the partitioned usage for different customers who are running their models in real time across in parallel. Um, and this is where the container model, which was basically used as an industry standard, whether you're using Kubernetes, Docker, or whatever, uh, starts to fail. As you can see, there's a physical GPU host, and it is being shared by uh, three or four different containers, each running their own models. So basically, if I try to explain you, there is something called MIG, which is basically multi-instance GPUs. That is an NVIDIA technology that allows you to partition a GPU and distribute it to multiple tenants. That allows you much efficient use of a GPU. Uh, but when you deploy it using a container is a very lightweight process, and it basically reuses your host operating system's kernel, and it does not have a kernel of its own. So when certain kind of errors are happening inside a model, they can trigger a kind of kernel level panics, which actually crash the entire GPU host. That means if container A over there was being used by one organization and container B, C, D that you see are some other organizations' workloads, uh, something wrong goes wrong in container A, and it basically crashes the entire GPU, and the other uh, organizations' containers are going to get disrupted. Um and this is a limitation in the container world itself. And a lot of companies in the West who have had, uh, last 3, 4 years of development in the AI, deploying these models, they have seen these challenges and have already tried to evolve beyond this and try to solve this problem. Uh, so basically, this basically explains why this basically happens. That you have just one copy of the NVIDIA driver, which is allowing you to partition the GPU. And if app A crashes, it crashes the NVIDIA host driver itself. And that means you have to restart the entire host kernel. So app B and C, although they are working fine, they were not really responsible for the crash, but they still have to go down and get the restart done. So when you see, this is something called GPU blast radius, that the blast was only in app A, but it started affecting apps of B and C, which are some other organizations. So this is not a good uh, scenario in this case. So the industry has made some progress around this, and what they have basically done is they have gone back and started using virtual machines to deploy these models, package them inside VMs, and the VMs have their own copy of a micro operating system or a microkernel, what you call. And if a crash happens, if you see on the diagram on the right, if the crash happens in the app A, it only crashes the driver and the kernel in VM1. It won't affect VM2 and 3. And basically, this allows the other two VMs to continue running while you can restart VM1, and that does not affect the other customers. And at the same time, it still allows you to partition the GPU, and it you are basically making more money. You're just renting out a single GPU to multiple customers, billing them. So the customers get it for a cheaper price, plus you get more customers per GPU. Uh, but the problem is with what kind of VM are you supposed to use? Uh, so traditionally, if you see, KubeVirt is one of the technologies that is very famous in the Kubernetes space right now, and I think it's 5 or 7 years old. Basically, it allows you to use Kubernetes, but instead of spawning containers, it will spawn your workload inside a VM. But as you can see, they are very heavy because it's basically a traditional VM. It will have its own entire operating system and everything. Uh, People have made some advancements in there with something called kata containers, which is a combination of containers and lightweight VMs, but it's still not the best solution. And the latest tech in this area is cloud hypervisor, which is what people call a micro VM. It's as close to a container as possible in today's time. And basically, it's just a very small operating system and I would say a microkernel where you have Linux and just a small number of modules of Linux, which are bare minimum, and basically you take your model, package into it, and run it on the sliced GPU. So this is the leanest possible thing right now in the industry. Uh, but the main problem is that all these things are kind of open source, but there are no solutions built around it. That is, as an organization, you actually have to, um, just go and take their source code, compile it, build a platform around it, like the whole thing. You have to do your own thing uh, for every organization. They would have to do a platform or a software taking these things. Like it's like there's no package solution around it. You can buy the bricks, you can buy the sand, but you have to build the house yourself every time you need to use them. Um, so basically, this is how it looks like in terms of a single GPU being partitioned, and each partition is given to a micro VM, and that micro VM. So this is basically an example of NVIDIA H100 GPU where it allows up to 7 slices. There are A10s which allow you up to 4 slices, and there are other Blackwell processors, GPUs, which are the newest thing in the market, which give you even more number of slices. So the companies on the hardware side are already doing this innovation, but mostly the companies like Google or AWS or Microsoft, these are the companies who have heavily invested in building solutions around the software layer, because you can build your models, you can get this hardware, but unless you are building companies or startups or software platforms to automate these things, package and solution them, you are basically still relying on Western providers or outside companies to actually hold power in this area. So you would have data centers in India which are running on our own power. We have our own models like Servam and other models that are coming up, which are trained from our own money. But how to use them, you don't have products around it. You are still dependent on foreign tech to utilize your own models and your own data centers for full potential. So, um, basically, this is how currently a lot of industry level standards are being used. When we talk about VM, a lot of people familiar with the Kubernetes and the ecosystem feel that okay, we are totally kicking out Kubernetes when we are saying we are not using any containers. But actually, there has been a lot of development in this area where people have developed technologies where you use the entire good things and the high technology that Kubernetes brings along with it. But instead of spawning everything at the end on the container, you actually plug in the micro VM or your custom VM and deploy it on a GPU. So The main innovation in this area is mostly around the micro VM part and how do you plug in into the existing solutions. Uh, and A lot of these things are open sourced, but you need to have your own solutions built around it and platforms that support these technologies working together uh, uh, to actually have a usable solution. But this is also a good part that if we start seeing a lot of people have this notion that we are already lagging behind in the whole AI ecosystem race, but this is actually the place where a lot of companies and startups can actually go and invest and do a lot of R&D and intellectual property creation that is basically going to get utilized in the coming 1 or 2 years as more and more models are being developed and deployed and more GPU data centers are being created. Um, Another aspect of this whole solution is that something called confidential computing, which is particularly important for the health and defense sector. So, confidential computing is not a very new idea, but up till now, when you were using containers, confidential computing was a very cash intensive, very expensive thing, and it was not something that was usable for any normal startup. The reason being that so the whole idea of confidential computing is that if you want to use public clouds like GCP, AWS, or Azure, uh, you basically would be doing this for if you're doing this for defense workloads. Basically, you have to trust that company that they're not doing any sniffing, data sniffing, or sending out your data at the hardware level. Like you just have to trust that, okay, so and so provider, if I'm running my model or if I am running my software on their hardware is not doing something fishy with my workload. So the whole idea of confidential computing was to give you as an organization a way to make sure that it is exactly what you're trying to run and it's not doing anything malicious, whether it be GCP or AWS or whatever. But since, as you can see, that it was encrypted on the fly, that is, when you put in the input, the actual output, all that was on encryption. It was very slow as compared to your normal workloads. So that has changed in case of GPUs. Now, GPU itself is a very powerful machine. And if you want to do confidential computing on a GPU, that becomes feasible even for uh, a normal company in terms of cost and in terms of performance as well, because you're running it not on a simple Intel CPU, you're running it on a GPU, so the workloads and the calculation and the encryption decryption required for every instruction that gets kind of normalized because of the GPU. And uh, the main requirement for confidential computing was that VM was a necessary part of confidential computing. Uh, there are certain organizations, maybe in some open source area, Microsoft has done confidential computing on containers, but then again, there was a costing issue. But this area is also opening up for a lot of usage now because we have GPUs, we have our own GPU data centers. So a lot of research can be put into the area of micro VMs or our own VMs for confidential computing that can be useful for the defense sector, the health sector, wherever there are sensitive data workloads. Um, so yeah, I mean, the whole talk here, I would say that we started from the left, where we just used to use uh, AI wrappers with Gemini or ChatGPT. That is how it all started around a year and a half ago, and we built some solutions around it. Um but now we are mostly moving into the space where we are trying to train our own models. We are trying to run them on our own data centers, and uh, that requires some additional tech to be developed here in India. And that is basically a good potential for a lot of startups and companies and a lot of R&D to take place. Um, yeah, and I think that is basically the new era that we are seeing today. There are models being developed, there are data centers coming up. So now it's part where we invest in efficiently utilizing both of these layers and start building in this area. Uh, yeah, I think that is the that's how I'll end it. If there are any question and answers, I can take it up after the stop. Thank you.